Amazing new revelation by scientists. They say Earth's spin is slowing down, and it's linked to a new theory on oxygen levels, of all things. The Earth's spin is slowing down, and scientists have a new theory that it could be linked to oxygen levels that helped early life form. And we have a video by NASA telling us how the oxygen levels change during the year. Now, half of the oxygen comes from land-based plants, and the other half comes from the phytoplankton of the oceans. So the oceans are very, very important in our oxygen production. Now, ever since its formation about 4.5 billion years ago, the Earth's rotation has been gradually slowing down, and its days have progressively become longer as a result. While unnoticeable to humans, it's apparently enough to work significant changes to our environment. And new research suggests that the lengthening of days can be linked to increased oxygenation of Earth's atmosphere. Specifically, the blue-green algae called cyanobacteria that emerged and proliferated about 2.4 billion years ago may have been able to produce more oxygen because Earth days grew longer. So they had more sunlight to, of course, produce more oxygen. Microbiologist Gregory Dick of University of Michigan says an enduring question in Earth sciences has been, how did Earth's atmosphere get its oxygen, and what factors controlled when this oxygenation took place? He said, our research suggests that the rate at which Earth is spinning, in other words, its day length, may have had an important effect on the pattern and timing of Earth's oxygenation. And the reason the Earth's spin is slowing down is because the moon exerts a gravitational pull on the planet, which causes a rotational deceleration. Scientists know, based on the fossil record, that days were just 18 hours long 1.4 billion years ago, and half an hour shorter than they are today 70 million years ago. Evidence suggests that we're gaining 1.8 milliseconds every 100 years. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.
When you think of NASA, you probably think of this. But as soon as we made it beyond the limits of our atmosphere, one of the first things we did was turn our cameras around and look at this. The first U.S. satellite was launched in 1958. That's 11 years before Neil Armstrong became the first person to walk on the moon. Explorer 1, built at the Jet Propulsion Laboratory, initiated a long legacy of satellites meant to take our understanding of Earth to new heights. In 1997, NASA launched a satellite that began a 20-year continuous global record of the very thing that, as far as we know, makes Earth special: life. While most satellite missions capture data on the physical characteristics of our planet's climate and weather, others allow us to measure life itself. The result? The most complete view of global biology to date.
The greatness of this dataset is kind of hard to explain. It allowed me to understand ocean in such an organic way.
That's the voice of oceanographer Dr. Ivona Sitanik. Ivona and the rest of the NASA Goddard Ocean Ecology Lab help oversee the 20-year dataset. If you take a closer look at this animation, you'll see what looks like a repetitious ebb and flow on the land and surface of the ocean. We're actually watching the planet breathe.
About half of the total photosynthesis on the planet occurs on land and half in the oceans.
That's Dr. Compton Tucker, who pioneered satellite monitoring of vegetation on land. The spring and summer months kick off the growing season for plants on land, illustrated in dark green, and tiny microscopic plant-like organisms in the ocean called phytoplankton, seen in the light blue. They take carbon dioxide out of the atmosphere and use it for energy, causing the total amount of carbon in the air to drastically drop. The opposite is true during colder months. During winter in the northern hemisphere, which is home to most of Earth's land plants, carbon in the atmosphere increases as plants go dormant. And then there are extreme zones in the ocean. Purple patches are nearly devoid of any phytoplankton. They're basically deserts at sea, while the red zones tell us that there's either a high concentration of phytoplankton hugging the coastline, or our satellite sensors are picking up on another input changing the color of the water.
We have a marvelous biological diversity of plants and animals, both on the land and also in the oceans.
But hold on. If we have an amazing biological diversity of plants and animals, why do scientists spend all of their time observing plants?
You know how they say you are what you eat? In the same way, if we want to understand the ocean and life in the ocean, we have to start from the base. If phytoplankton is changing, the whole ecosystem will change.
The changes that Ilona is talking about are much easier to see when we can study a continuous global record. And that means not only being able to look into the past, but also into the future.
It's this long-term data set that allows us not only to see exactly what's happening, but to be able, so much better way, to predict what's going to happen.
A global perspective gives scientists the power to forecast events like harmful algal blooms, disease outbreaks, and even famine. Maybe one of the most useful applications of the data is its ability to show us where we've been. In 20 years, the planet has changed in noticeable ways, and this dataset gives us a visualization to prove it. Arctic greening coupled with retreating Arctic sea ice are probably one of the most well-known examples of this.
If you look at the higher northern latitudes, you see in the white where there's snow, and that then moves further north into seas. It's then followed by very, very green colors because plants are really photosynthesizing in those dark green periods.
Scientists think that there are likely trillions of planets, yet Earth is still the only planet we know of with life. And with that in mind, our habitable homeworld seems ever more fragile and beautiful when considering the vastness of unlivable space.
I have several friends and acquaintances who are astronauts. They all say the same thing. When they're in orbit, on the space shuttle or in the International Space Station and look down at the Earth, they see one climate, one planet. We're all in this together, and we need to work together to make sure that life as we know it continues on this wonderful planet.
So evidence suggests, as the scientists explained, that we are gaining 1.8 milliseconds every 100 years. The second component is something known as the Great Oxidation Event, when cyanobacteria emerged in such great quantities on our Earth that the atmosphere experienced a sharp, significant rise in oxygen. Experts even theory that life as we know it may not have emerged without this event. And their study, which was published yesterday in Nature Geoscience, proposes and puts to the test the theory that longer, continuous daylight kick-started weird bacteria into producing lots of oxygen, making most of life as we know it possible. They dredged up the gooey bacteria from a deep sinkhole in Lake Huron of the Great Lakes in North America and tinkered with how much light it got in lab experiments. The more continuous light the smelly bacteria got, the more oxygen they produced. Researchers believe that there may have been similar competitions between communities of microbes billions of years ago, with oxygen-producing bacteria's sunlight exposure hampered by their microbial neighbors. They concluded that Earth's slowing rotation, which gradually lengthened days from 6 hours to the current 24 hours. Can you imagine? Only a 6-hour day to now 24 hours was key for the cyanobacteria in making the planet more breathable. The study lead author was Judith Klatt, and she said, "We realized that there is a fundamental link between light dynamics and release of oxygen, and that link is grounded in the physics of molecular diffusion." And she said a shorter day would allow less oxygen to escape a mat, even if the same amount of oxygen is produced every hour, of course, because we only had 6 hours as opposed to 24 for the day. This is by Callum Hoare, Express UK. I think this is fascinating, a fascinating finding. and as our Earth's spin is slowing down. Please leave your comments and thank you for your support.